So this is Phineas, and I'm demonstrating the second part of the 256 bit, the part two, which is the 256 bit basically. And yeah, let's get right into it. And so the steps are 16, and the first step is to write memory register one. So that is I combine those, and I write one with one. So memory register zero of memory chip zero. So this is the first memory chip, second, third, fourth. And I'm supposed to write it with one, and we write it. So I use the RD like a reset, but the R it's still a read. So yeah, it's in there. And then the second one is supposed to go into first register, and you turn it on, and it's stored there. Perfect. So now we go to memory chip two, which is um, that. So as you can see, nothing is written into memory chip two, and then it's gonna be that, and then we turn this on, reset the read, and it should be four. Mm-hmm. Um, we've written that, and then we in the same memory chip we write eight. So we turn that on, but we add one there, and then we reset, and eight is written there. So it has been written. Turn this on, then we go to the third memory chip. So I'll turn this one off like that. And turn all this one on because we are now 100, and turn this off. So if I switch this off back on, this should be on. And yeah, so that has written that. And so our next is going to be 101 onto the same bank. So like that. And when I do this, it should be written now. And then in 110, oh, I should probably put this back on before switching. In 110, we're gonna have this written there. And it's gonna go into the third. So that's probably all of them off into the fourth bank. Yeah, and when we switch that, we have written it, and it should be in there. And then the last one, same memory chip, 30, third one, three, because this one's zero. It's technically a fourth one. Um, we turn this one on, and eight will get stored into that, and we turn it off, and then it's written. So now we go to step nine. We've written everything, and now turn all the top ones off. And now this should be a demonstration of basically how everything is. So in memory chip zero, so this both were on um in zero. As you can see, one, it displays one, just like um that had been stored. And when we turn this one on, um this should turn off. And the bulbs represent the zero. So it's two. Then we switch our memory banks, and we go to the second one and check for number two. See if four was stored in there. And as you can see, 4 was stored in there. And in the same memory bank too, we check if 8 was stored. And when you turn this on, 8 was stored in there. We switch to memory bank 3 and check if 1 was stored for the second one. For the second 4-bit digit uh, output date. Turn this on and it should show. Oh, whoa. Did I skip a part? Oh yeah. No, no, no. That should not be on. Yeah, I may have written something wrong. Um, so that should be on. Wait, wait. Um, so we had 0, 0. So we want this one to output a 1, and that should be, oh, that should be in chip um 2, this memory chip. And we may have written that wrong. Register 4. This is register 4, so it's supposed to be. Okay, I'm gonna rewrite that again. Um, yeah. Okay, so now we are good. Yeah, so 1 was stored there. And then in the same memory chip 2, we go to 5, and then 2 should be stored there. Yes. So I guess the little reset that I did not work at the beginning, and that's why it had been overwritten to 2 when it should have been 1. So yeah, and then we go to our last memory bank, which is 4, and we'll find 110. I stored 4 there. And then when I press this, it should be 8. And that was the demonstration of the 256-bit memory working. Yeah. So we wrote all the registers and we read all the registers. Thank you.